Hi, welcome to the topic structural or constitutional isomers. In this topic, you will study varieties of constitutional isomers. Coming to the introduction, compounds that have the same molecular formula but different chemical structures are called isomers. Remember, isomerism is a property between a pair of molecules. That means a molecule is an isomer of another molecule. A similar relationship is that of a brother or a sister. You can only be a brother or sister to someone else. Depending on the nature of the differences between the substructures, the isomers are classified into various subtypes. This is a flowchart showing the relationship between different isomers. If your compounds have same molecular formula, if your answer is S, then they are isomers. If your answer is no, then they are not the isomers. Yes, if suppose your answer is S and they are isomers, then you have to think, do the compounds have the same connectivity? Yes, if your answer is yes, they are stereoisomers. If your answer is no, they are constitutional isomers. Coming to the definition and properties. Constitutional or structural isomers differ in order in which the atoms are connected together, so they contain different functional groups or binding patterns. Structural isomerism is when the molecular formula is the same but the structural arrangement of atoms is different. The shape of the carbon chain, the functional groups, and the position of atoms and groups in the molecule may be different. Always the structural isomers will display different chemical and physical properties, but more branching lowers the boiling point. Now, let us see the types of structural isomerism. The first one is chain isomerism. Branching will happen or branching will occur in the carbon chain. Example, butane C4H10 has two chain isomers. You can see here the structure on the left hand side is a long chain with 4 carbons and the right hand side is a branch chain with a carbon chain length of 3 and the extra methyl group is attached to the second carbon. So one is a straight chain molecule where all the carbons are in a single row and the other is a branched molecule where 3 carbons are in a row and 1 carbon atom sticks out of the main chain. The other example is pentane, that is C5H12. It has 3 structural isomers: N-pentane, isopentane and neopentane. N-pentane has 5 carbons in a straight chain. Isopentane has 4 carbons in a straight chain and neopentane has 3 carbons in a straight chain. Next comes the positional isomerism. These occur from the basic carbon chain staying constant with the overall molecular formula staying the same, but the important groups such as halogens, alcohol group or benzene group or any other group may move around that carbon skeleton. Here we can see an example for positional isomerism. C3H7Cl, which is a chloropropane, can exhibit this positional isomerism. It shows 2 positional isomers occurring when the chlorine atom is attached to either the middle carbon or the end carbons. So here we have 2 positional isomers, 1 chloropropane and 2 chloropropane. Next isomerism is functional isomerism. Same molecular formula but have different functional groups are functional isomers. Here the example shown is C3H6O. This can exist in two forms according to functional isomerism. The left-hand side is propanol and the right-hand side is propanone. The left-hand side is an aldehyde and the right-hand side is a ketone. The fourth one is metamerism. This is a type of isomerism which is formed due to unequal distribution of carbon atoms on either side of the functional groups. Embers belongs to the same homologous series. Example, ethers, diethyl ether and methyl propyl ether. In the first ether, oxygen is occupied by ethyl groups on either side. But in the second structure, which is on the right hand side, oxygen is occupied by methyl group on the left hand side and the propyl group on the right hand side. The last type of structural isomerism is tautomerism. Special type of functional isomerism in which the isomers are in dynamic equilibrium with each other. Example, ethyl acetoacetate. It can exist in two forms, that is keto form and enol form. They are always in equilibrium with each other. Thank you so much. Here we end our topic of structural isomerism.